Hello everyone, welcome to the Open AGI Forum. I'm Echo Tang from CSDN. And today, live from the GOSIM Conference Europe in Delft, we are honored to have Steven Pemberton from CWI join us. He's got plenty of legendary stories to share. Welcome, Steven.
Thank you.
And first off, how did you first get into computers and programming? And what inspired of you pursue a career in computing? Could you share the story of your tech journey with us?
Yeah, so I went to university to study electronics at a time when electronics was a really exciting period. Computers were up and coming, still not yet in the home, still industrial things really. And I had the good fortune that my tutor, I went to a university that had a tutor system, which is where you have one-on-one talks with the professor. He was the man who'd built the very first transistorized computer. And at the time I didn't know that this was important, but his tutor in turn was Alan Turing, the person known for being the father of computing in Britain and the father of AI. So during that course I learned programming, and so when I left university I looked for a job in programming, and in fact I got a very humble a job for a while, just typing in data for a research institute or for a research center. But they knew that I could do programming, which I'd learned during my course, so they gave me programming tasks to do, and I really got into it. I loved it. And so within 3 months of working there, they employed me as a programmer. And so it was a great environment. I had a lot of freedom to learn. I was doing programming for research projects, which was in itself very, very interesting. And I got very involved with learning about new things in computing. And funnily enough, one of my sources of information was the Research Institute in the Netherlands, because what I'm talking about now is in the UK, which is where I grew up. And one of my sources of information was this Research Institute in the Netherlands, where I work now. So I learnt about them at a very early stage and found what they were doing was very exciting. And it took a number of years before I ended up here, but eventually I ended up at that Research Institute.
Wow, that's very exciting.
Yeah.
And then I want to ask a question. Looking back, how do you view your early work in tech and the impact it had led on?
My early work, well, so I worked at this research center for 2 years as a programmer, and then I got very much into what was then a new programming language called Algol 68. I saw an advert for a programmer to work on a new Algol 68 system, a compiler, in Manchester, and that looked to me like my ideal job. So I applied for that and I got it, and so I ended up in Manchester, which, as it turned out, was Alan Turing's old department. Completely coincidentally, nothing to do with the fact that my tutor had been in that department as well. So I ended up in that department working on a research computer, which was called the MU5, and it was 5 because it was the 5th computer in the line of computers that Turing had started work on. So that very much got me involved in real research, because now I was doing research. My previous job had only been supporting research. Now I was doing research. I was involved in a research project, producing software for it. So that was a very good learning experience. When that project was over, I went back to Brighton, where I lived, and I became a university lecturer. And I still continued working on programming languages, and I wrote a book at that time on a Pascal compiler. So all of this was very much just providing the beginnings of my career, really. And it was only at the end of the 5 years there that I got invited to come for a sabbatical, just for a single year, to Amsterdam to work at the Research Institute, that my career really started up.
Okay, and you are often introduced as a student of Dick and indirectly linked to Alan Turing as his intellectual descendant. Did such reputations impact you when you were younger?
So, I mean, I was very young. I was a student. So at that stage, everything was new. I was learning everything. The fact that my tutor had built the first computer at that point wasn't really important. I mean, he was an inspiration in some ways, but I didn't see my future at that point as in building computers, for instance. So I think it's more just a spark that set me off in the direction of computing rather than being directly inspired by what he had done. On the other hand, I mean, of course, I've always followed Turing. I mean, I've read his works and know what his development was. So, it's always been in the background for me, but not until very much later did it become more of an inspiration in the direction that I would go.
Okay. And the next question is, you've met many geniuses in the fields of computers and science. What are some valuable traits you've observed in them?
Well, so as I said, when I was starting off as a programmer, one of my inspirations was the Research Institute where I now work. And in particular, there were two people there who influenced me quite greatly. One was Edsger Dijkstra, who's a very formative computer scientist. He's had a big effect on computer science in general. And his writings very much affected me at an early stage and helped me understand how computer science is very much a discipline. I think a lot of people don't understand even now, the discipline of computer science, and maybe that's because there's such a need for programmers that people are becoming programmers from diverse fields that don't have a necessary computer science background. So there's I see a lack of discipline in computer science in lots of ways. It's a wild west at the moment. Still, lots of things being developed in very haphazard ways. But Dijkstra influenced me very greatly, and the other person was Aad van Wijngaarden, who was the director of the CWI at that time, and he influenced me in lots of ways via this programming language, Algol 68, which I think was interesting because it was, in my mind, the first programming language that was designed for the programmer and not for the computer. It was designed in a very consistent way that you don't see in a lot of programming languages. And it had a very elegant design, although a lot of people didn't see that at that time because its definition was very mathematical, and that put a lot of people off. But the language itself was extremely elegant, very forward-thinking, and has produced a lot of influence, even though people don't know it. I mean, for instance, the word dereference, which everybody uses nowadays, comes from that programming language, and people don't know the link. But dereference was invented in Algol 68. So I don't know if I've really answered your question, but these are the things that influenced very early on. And luckily, all coming from Amsterdam, and then I got drawn into Amsterdam, and so I ended up here too.
And the next question is about AI.
Yes.
I've seen some of your talks on AI and your experiments with ChatGPT. What are your thoughts on today's AI? Any visions for AGI?
This is going to be a long answer. So I give a course every year now on AI at Oxford University in England. An introduction to AI, so it's fairly low level, which is where I use these chats with ChatGPT as a demonstration of how it works. So the most important thing, I think, for people to understand is that and the title of my talk is There's No I in AI. That is to say, it's not intelligent. We call it AI, but that's incorrect. It's not yet intelligent. It's machine learning. And the reason that we think it's AI is because we can't imagine something producing answers to our texts, or to the things that we type or say, producing such answers if that thing isn't intelligent. So we interpret it as intelligent, whereas in fact the word that's used is stochastic parrot. It's just parroting things that it's learned back to you, but there's no deep understanding there. And that's why the AI programs make blunders, and we're so surprised. How on earth could it make such a big mistake? And the answer is because it's not intelligent. So I think that society is not yet sophisticated enough, because AI, these things we called AI are so new, to understand the difference between machine learning and artificial intelligence, and that we haven't got intelligence yet, and we should understand that the things that are being relayed to us via these programs is a reformulation of other stuff that this machine has learned, and that therefore you should be very you shouldn't trust. You should be mistrustful of what it says. You should interpret what it says. You might use it to help you generate your own stuff, but you shouldn't take it on board literally. Now, the second part of your question was about general intelligence.
Yeah.
And that, I fear, is a great danger. The danger being that once computers become truly intelligent and as intelligent as us, then all of a sudden there's a new sort of being on the planet that if these things are self-aware as well, they're intelligent as us, they're self-aware, do existing laws about people, for instance, apply to those computers? And I don't really see why not, because it's a self-aware intelligence. It might not have any power to be able to do things, but it is an intelligence. So, for instance, once we have these things, is it ethical to switch them off? And to help you understand what I'm trying to say here, imagine that we work out the way of uploading our brains into these general intelligence, so that once you die, you still continue to exist, but as part of a general intelligence. Is it ethical then to turn that machine off? I think these are questions that need to be approached. The next problem, though, is that once these machines become as smart as us, there's no reason why they won't then start doubling in intelligence, becoming twice, 4 times, 1,000 times more intelligent than us, and then seeing some of the problems in the world. And the question is, will these new intelligences be our friends or not? And there are 3 possibilities. They might be completely neutral. They might be very selfish and only be interested in protecting themselves, or they might be our friends. We just don't know, because we really don't know how artificial intelligence works, and when it finally becomes totally intelligent, we really won't know. I anticipate we won't know how these things work, that they'll just be intelligent and we've created a mechanism, but we won't know what it is that makes them make certain decisions. And so the question is, will it be on our side? Now, if we look at ourselves and less intelligent creatures on this planet, how do we treat them? I think we're actually not very good at treating lesser intelligence. That animals that are useful to us, well, we might feed them for a while before killing them and using them. Animals that are neither harmful nor useful, then okay, we don't really care whether they live or die. And animals that we don't like, we're quite very happy just to kill. You know, a mosquito or a wasp, we would have no compunction at killing those animals. So the question is, will artificial intelligence have the same sort of opinion of us as us? If they have the opinion of, yeah, lesser intelligence, okay, well, we'll let them live. That's the least. That's the medium case. But the worst case would be, oh, we've got a climate crisis. Why is that? And then they'll discover that we are the source of the climate crisis, and they might then find out, well, the solution to the climate crisis is to let 90% of the humans die, because they'll all be connected to the internet, they'll be smarter than us, they'll be able to break into every single manufacturing or producing a factory in the world, and they, I'm sure, will have the power of switching those things off for 2 weeks until a number of people have died. So, I mean, you know, that's a very it's not a very good-looking future, but I don't see, it's not out of the question, and I don't anticipate how we can prevent that happening except by ensuring that artificial intelligence is never connected to the internet.
Okay, and for developer in China or in USA, we often say the programmers is very about it because the maybe AI will replace the programmer.
Yeah.
What do you think about it?
Well, you know, the possibilities are great, and on the one hand, why not? You know, I mean, the opportunities for making people's lives better are great. I mean, a lot of programmers don't enjoy, I mean, some do, sitting behind the computer for 20 hours, well, 20 hours, it's going 16 hours a day writing programs. Some really enjoy it, and that's their real life, but a lot of people would rather be at home with their families. So if we could replace work with computers and robots, that would be fantastic. But there's no image at the moment that society will use these things for making people's lives better, which is, I think, terrible. I mean, there's such an opportunity of making people's lives better. I mean, if we could reduce our working day to 4 hours a day, that would be fantastic for everybody. And if we could use robots and artificial intelligence to do that, that would be great. I don't see it happening because the people in control don't see that as advantageous for them, is my guess. So I'm a bit negative about that. But the opportunities are great, but I don't think that the reality will work out that way.
And any question, any advice to developers?
To developers?
Yeah.
Well, at the moment, I'm not impressed by the quality of code that's produced. And the reason that I'm not impressed is because AI, machine learning, which is doing the work for you, has learned how to program from examples on the internet. And frankly, most programmers are not very good. You know, there are some absolutely brilliant. I mean, it's like sport, you know. There are a handful of people who are absolutely brilliant sporters, and then you have the rest who are, you know, sort of just moderately good, and then the rest who are terrible. Or, you know, footballers, or, you know, any part of life, cooks, drivers, everything. There are some who are really, really good and some who are absolutely terrible, and then in the middle you just sort of have average. So a lot of the code that's produced that machine learning has learnt from is a pretty average to poor quality. So the stuff that it produces is also going to be not that great. So you would need better quality artificial intelligence to produce better quality code. You can't trust the code that it generates yet. You still have to check it. You can't say, write me this program and then run it. No, you have to say, write me this program, and then you have to check that it really does do that and still test it. Okay. Because it's just as likely to have bugs as if a programmer wrote it.
Okay. The next question is about open source.
Yeah.
What role do you think about open source plays in all this?
Well, I mean, I think open source is absolutely essential. I'm a big supporter of open source. I produce it myself. I use it all the time. I think it's a fantastic movement and absolutely essential. You know, a lot of the infrastructure that we use today is open source. You know, Linux. You use Linux 10 times a day without knowing it. You know, it's in your telephone, it's in your router, it's in your laptop as well, it's only a good thing.
Okay.
It makes the world a better place.
Okay, and about HTML.
HTML, yeah.
What do you think the next steps in its development might be?
Well, so I have very strong views about this, and I recommend anybody watching this to watch my talk called The 100-Year Web, where for 45 minutes you will get my complete answer to this story. But HTML has taken a wrong turn recently. It used to be an easy-to-write format for people who weren't necessarily computer people, who could produce useful stuff. But in the last few years, it's turned into a programming environment in which, firstly, you have to be pretty good at programming in order to do anything properly. And secondly, it's meant that you've got a lot of so-called frameworks in order to build your website. So HTML is no longer good in itself. You have to use HTML plus a framework. And there are 25 of them. Which means that you've now got 25 different types of HTML, which is terrible because it used to be just one HTML and now you've got 25. That's exactly the opposite of what you want. You want standards so that you learn one thing and produce it. And this is because the people who produced the current version of HTML, they didn't do a very good job at designing, and they said, if you need anything new, you can do it in programming. That's because they were programmers themselves, rather than thinking about what people really needed and putting it into the language and supporting people's true needs. So I think HTML has got terrible because it's based on programming. And what I think that this also means is that it's damaging the long-term sustainability of the web, because much of our knowledge and information now is only available via the web. A lot of books have disappeared, especially reference books, so that a lot of our information is now only available via the web. And you want that information to remain on the web for the next 100 years, the next 200 years, because it's part of our history. You don't want to lose history. So you want it to stay. But I can't imagine the websites being produced today still running in 100 years' time using a 100-year-old JavaScript implementation, using a framework that hasn't been supported for 75 years, that doesn't necessarily work in browsers anymore. So I think they've taken the completely wrong direction with HTML, and that is the first thing that needs to be fixed, really, in a future web, that we need to get back on a more sustainable route to information rather than programming. Programming is the wrong approach to dealing with information.
Okay, and then the ABC language you designed
right.
was initially meant to replace BASIC.
Yeah.
And later Python, which was inspired by ABC, took on that simplicity and became globally popular. Now it seems we are entering an era of natural language programming. We see a trend towards simplicity and the years of learning in programming language. What are your thoughts on this trend? What do you think the future holds for natural programming language?
So, okay, long story again. So, ABC, yes, I came to Amsterdam. In fact, I was invited to Amsterdam to help work on this programming language that eventually was called ABC. It's historically interesting language, I think, because it was the first programming language built using user interface principles. That is to say, you do a user requirement. So I said earlier that Algol 68 was designed with the programmer in mind, and we took that much further. So we did requirements of the programmer, and we tried to address the programmer's needs first and not worry about how to implement it. So we designed the language and then tried implementing it, which was interesting in itself because it demanded us to research new ways of doing programming language implementation. The language turned out very small but very powerful. So I compare it with the difference between automatic car gears and manual gears, that automatic gears are much easier to use, but the implementation underneath it might be harder. But you know, that's fine. It should be hard for the implementer if you can make it easy for the user. So it's a very easy to use programming language. I still use it myself daily because it's actually very powerful. And we discovered a principle behind programming languages that most programming languages are designed at a low level, giving you low-level tools in order to build high-level tools. And what we discovered is that there's a number of high-level tools that every programmer needs everywhere. And if you build those into the language, you don't have to build them yourself, and you've got them immediately available. Things like sorting and searching are primitives in the language rather than having to be built into the language. So that makes those things also very fast, but it makes the language very quick to use and very easy to use. So that was a very good lesson to us, and although ABC in itself didn't become a globally used, well, a widely used language, it became the basis of Python, which is now the #1 used language, I believe, because Guido van Rossum was working on the project as well. He moved to an operating system project and needed a lower level language and built it based on what he'd learnt in ABC. That's part one of my answer. Part two of my answer is an observation that when programming languages were first designed in the 1950s, and we're talking about COBOL, Lisp, Algol, Fortran, those are the main ones, I think, built in the 50s. You had an economic relationship between computer and programmer. That is to say, a computer was very, very expensive, let's say $1 million. And a programmer, compared with the cost of the computer, was almost free. So that meant that you wanted to save the computer's time as much as possible, and you didn't care whether it took a long time to write a program. So programming languages were designed with that economic relationship in mind. Let us make the task for the computer as easy as possible, even if it takes a long time to write the program. But in the 80s, that line crossed, and that's at the point that computers and programmers started being about the same price. And nowadays, compared to the price of a programmer, a computer is almost free. But we're still programming in languages that are visibly descended from the programming languages of the 50s. We haven't yet made that mental shift. Oh, it's the programmer who's expensive now and not the computer. And we should be devising languages that now think about the programmer and don't worry about the computer. So that's what my research is now in programming languages. It's called declarative programming, where a procedural language, the old style, you've got a problem, you tell the computer step by step how to get to the solution. In declarative programming, you describe the solution and you let the computer work out how to get to the solution. It doesn't have to be with AI. In fact, we're doing it without AI, although in the future you could use AI for that. And the example that I use of declarative programming that people already see is spreadsheets, which is a very small area of problem solving, but you specify the relationship between different values. And then any time a value changes, the whole thing gets changed again. But you haven't done any programming for that, you just specified relationships. And so in our declarative programming language that we're designing, which is called XForms, we do exactly that. We describe the relationship between data and then let the computer loose on it, as it were. What we've discovered is that that can cut your programming resources, the time you need to write a program, to at least 1/10, and in some cases to 1/100th of the time necessary. So it's much faster, much more powerful. You can get things done in comparatively no time. So I think that that's the direction that programming languages should be taking in the future. And I believe that once programming managers discover that they can cut their resources to 1/100th, I think that the switch to declarative programming will happen.
Okay, thanks, Steven. And that's the question. For many programmers, new technologies can bring anxiety and panic. What skills or mindset do you think are important to cultivate at different stages of a career? Yeah.
Well, I mean, the important thing, I think, for a programmer in general is not to live in a monoculture. So you not only, so your day-to-day job will, of course, be using a certain language, but you should be au fait, you should be conversant with not only a number of different languages, but also a number of different language types. So you shouldn't only be programming procedurally, but you should know how to program in object-oriented or in functional or in declarative programming languages, just to make it helps you think about problems in different ways. I mean, it's a fascinating. I found it a fascinating evolution for me, learning how to program declaratively, because what I've discovered is that I look at problems in a completely different way, and I feel that that's very very advantageous. Another important thing for programmers that programmers have the habit of doing is not thinking at too low a level. A lot of programmers think in terms of how the computer works, and that very much affects how you think of problems. And you should try and learn to think more in abstractions. What is the abstraction involved before you start trying to solve the problem?
Okay, thank you, Steven, for the exciting discussion, and thanks for our developers watching. That's all for today's interview. See you next time. Goodbye.